Before I actually give you a warm-up, we're going to go through some basic definitions again about key terms and about what vertex form looks like. I had a lot of questions as we were working yesterday on the back side of the homework. You forgot that form and couldn't figure out the vertex initially unless you went back and looked at your notes. So, vertex form. So again, I'm just giving you some general things and then we'll actually do a warm-up. So vertex form. Our full vertex form is y equals a times x minus h squared plus k. That's if it has everything included. Okay, so that has your h and your k included. But it could also look like this. That's also vertex form. What's missing? K, which means your y value is 0. Okay, you know what your x value is, your y value is 0. It can also look like this. What's missing? The h, which means your your x value is 0. It tells you what your y value is. It could also look like this. What's missing? H and k, which means your x and y values are 0. Okay, it can be in any 4 of those forms and it is still vertex form. You have to be able to identify what's missing and what's there. If something's missing, your value is 0. We know that the vertex is HK, and what's special about either one of those? Which one's opposite? H is opposite, K is the same. So H is opposite sign, K is going to be the same. Your axis of symmetry is x equals. And what is it going to equal?
So when we wrote H is going to be opposite, is in the same, do you mean like when one of them isn't there?
No, so if you have H, it's opposite sign. So if it was a -3, it's going to be a +3, and then whatever's at the end for K is going to be the same. Okay? Axis of symmetry, x equals what? H, it's the x value of your vertex. Once you know what H is, you can find the axis of symmetry. What's the domain? All real numbers. I even gave you drop-down menus yesterday. You didn't have to think very hard on some of them. Range. We have 2 options. We have y is greater than or equal to k, or y is less than or equal to k. First of all, why did I choose k? It's the y value of your vertex. And how do we know when to use greater than versus less than? Okay, which one's up? The greater than. So when your parabola opens up, you're going to use the greater than. And when it opens down, you're going to use the less than. This is all review of the key terms. What about orientation? Whether it goes up or down. How do we determine if it opens up or down? The A value. So if the A value is positive, it opens up. If the A value is negative, it opens down. Shape. We have three options. We have when A equals 1, when A is greater than 1, and when A is less than 1. And I would like you to write a note to yourself. Do not look at the negative sign. I'm going to put positive sign there. Do not look at the sign. You're just looking at the number. So when A equals 1, what happens? No change. When A is greater than 1, what happens when A is greater than 1? It's a stretch, which means what? Okay, so it gets skinny. And when A is less than 1, it's a compression, which means it gets wider. Last thing we have is the max and min. And the max min value is going to be what? What is the max or min value going to be? The y value of your vertex, so it's going to be your k. If we just keep in terms of the letters that we have. And we know that for a maximum, which way does our graph open? If we have a maximum, it opens down. And if we have a minimum, it opens okay. I'm going to give you two problems. Here is all the information you need. You should be able to identify the key features. Here's everything you need for those two. So take a few minutes and identify all those key features. We are going to take a little break from graphing, but we're still going to deal with quadratic equations. So we're going to talk about the differences between vertex form and standard form. We're going to switch between them. We're going to write equations, do a bunch of fun stuff. So first and foremost, what is vertex form? I'll give you a second to write that. And then we need to figure out what vertex form is. I've seen like 2 people flip to their warm-up because we wrote it. Brianna, you want to tell us? Good. So vertex form. And I'm giving you the general one. Remember, I just gave you 3 other ones that are still vertex form. They're just missing pieces. And then we also have standard form. Who can remind us what standard form is? Y equals ax squared plus bx plus c. Other than the a, the x, and the y, what do vertex form and standard form have in common? Other than the a, the x, and the y, what do vertex form and standard form have in common? They both have a squared. Super important. Okay? Any equation where the highest exponent is a 2 means it's a quadratic equation. So quadratic equations, highest exponent is going to be a 2. So for it to be a quadratic equation, the highest exponent's a 2. That means when you graph it, you're going to have a parabola. It means you can use the quadratic formula on it. It means you can factor. It means you can take square roots or complete the square. So all the things we've learned this semester we can do with quadratic equations. But our highest exponent's going to be a 2. So if I gave you a handful of equations, could you determine if they're quadratic equations or not? Yeah? Okay. So I'm going to give you 4, and I want you to identify if it's a quadratic or not a quadratic. Okay?
Okay.
So let's go with so write out these 4 equations, and I want you to determine if they are quadratic. If they are, just write quadratic next to it. If they are not, write not a quadratic. So based off of what we just said a quadratic equation is, are each of those quadratics? All right, it should be pretty straightforward. F of x equals x plus 1. Is that a quadratic equation? No. Why not? Doesn't have an exponent of 2. What is the highest exponent on this one? A 1. There's a 1 there. So this is not a quadratic. What about f of x equals x squared plus 2x minus 6? That is a quadratic. Because of that too. What about f of x equals 2 to the x? Okay, so it's not a quadratic. It's actually known as an exponential function, which you will learn about next year. And then what about the last one? It is a quadratic. So if I asked you that question on a test, could you answer it?
Yeah.
Yeah.
Oh, yeah, yes.
Okay. Yes, we could answer it? All right. We're doing a lot of different things today. We're just kind of taking a break from graphing. So we are going to rewrite a quadratic function from vertex form to standard form. It's going to be so much fun. So we're going to rewrite this function from vertex form to standard form. So I gave it to you in vertex form. Our goal is to put it in standard form. So y equals ax squared plus bx plus c. I want you to take a look at that, and I want you to come up, I don't want you to do any math, but I want you to come up with a plan with your group on what you could potentially do to rewrite it from vertex form to standard form. You need to think of everything you've learned this semester. How would you rewrite it from vertex form to standard form? Talk to your group right now. I'm going to come around and ask people. Okay, so we cannot distribute the 4. We cannot distribute the exponent. But what I can do is rewrite this as 4 times x minus 6 times x minus 6 plus 3. Does that look at all familiar to you? It does? What would you potentially do before you actually do it? Multiply what? These two sets of parentheses? How do I multiply x minus 6 times x minus 6? The box or foil.
Oh, yeah. I forgot about
I said you had to think back to the beginning of the semester, so let's go back to the box. If you remember how to foil and you want to foil, that's fine too. I'm going to do the box with you. Okay, write it down. We're going to do it together. Okay, we have x minus 6 and we have an x minus 6. Remember, to get in the box, we're going to multiply. This is also a good review because it will be on your final exam. So to get in the box, we multiply. What's x times x? What's x times negative 6? X times negative 6 is negative 6x. Negative 6 times negative 6? Positive 36. Anyone remember what's special about the box?
They always are crossed like that.
The diagonals are your like terms. Okay, so I'm going to rewrite my equation before I pull out my like terms. So I still have this 4, right? And then I'm going to rewrite what I have here. So I have x squared, combined like terms, is a minus 12x plus 36. Plus that 3 at the end. So x minus 6 times x minus 6 gave me now what's in the parentheses. Does that look familiar? How would I finish that problem now? Distribute the 4. You are now allowed to distribute the 4 because there's no exponent. So if I distribute the 4, I have 4x squared minus 48x plus 144 plus that 3 on the outside. So final answer is y equals 4x squared minus 48x plus 147. So it's not new information, but it's information you have to be able to recall so that you can rewrite it. Okay. Can I give you one to try? Well, you're going to get one either way. So let's do y equals negative 3 times x plus 2 squared minus 1. So take the same steps and apply those same steps to rewrite it in standard form. Yes? Here we go. So first thing would be to separate and write x plus 2 times x plus 2 and then have everything else attached. If I do the box or foil, whatever one you choose to do, I have an x plus 2 and an x plus 2. Inside the box, x squared, 2x, 2x, 4. So y equals negative 3 times x squared plus 4x plus 4. Now I can distribute that negative 3. So negative 3x squared minus 12x minus 12 minus that 1. Final answer. Y equals negative 3x squared minus 12x minus 13. How'd you do on that? Great? Okay. We are going to stop and not do something new today. So listen carefully though. The homework I give you tonight will also be part of your homework tomorrow. You're going to do half tonight, and then the few questions tomorrow after we finish notes, you'll probably be able to finish in class. So once I pass it out, I'll tell you exactly what you're doing, okay?